So good afternoon, bon après-midi. I am Jason Ivo, Science and Tech Advisor at the Office of Energy Research and Development at NRCan. So Marie-Claude, I am one of those feds in the crowd. I'm joined by my colleagues in, yeah, it was just kind of fun. Joined by my colleagues in Immigration and Global Affairs as well. So if you want to chat with any of us, we're in the crowd, please do feel free to reach out. So our shop delivers R&D programs and a range of other non-funding activities for energy innovation. And I want to make sure everyone in the room is aware that we currently have an open call for proposals for AI for Canadian energy innovation that will support applied research, development, and demonstration of Canadian-made AI solutions. So the call opened in October and closes on December 4th. So if you're interested, please check out the NRCan website for more information. And I also wanted to add that OERD, we have a mailing list for our energy innovation program. So if you want to keep up to date on new funding portfolios that are coming out, just subscribe to the mailing list. And also, if you want to see beyond the OERD in other parts of government for funding opportunities, you can connect with the Clean Growth Hub. And so I'll make sure to prepare a slide on this that everyone can access after the conference. So in the smart grid portfolio, which is where I work, we've seen AI move from fringe to mainstream, where utilities are embracing AI-enhanced solutions to plan and operate distribution systems more effectively and efficiently. And leveraging demand-side management and customer-sided DERs is now central to utility strategies for resource adequacy, reliability, and affordability. But if we want customers to transform into true grid assets, then customer engagement isn't optional, it's mission critical, which has launched this fascinating and complex journey into behavioral science. And that's why this panel is so exciting. So we'll hear about the cutting edge research at the intersection of AI and behavioral science, some of the tools shaping this frontier, and lessons learned from real world pilots. So we'll start with 3 short presentations from each of our speakers on what they're working on, and then we'll move into a guided discussion to dig deeper into some of the key concepts and insights that they've shared. So I'd love to call up my fellow panelists onto the stage, and I think, Sarah, you're up first for your presentation.
So, Sarah Mudge, I'm an electrical engineer with NB Power, and I have the great pleasure of currently working as the senior technical lead on the Smart Grid Atlantic project, but also with energy efficiency services. So as Jay explained, my entire world is basically behind the meter, and how do we engage homeowners, businesses, in a way that allows us to help them better manage their energy use to better ensure reliability and security of the grid on their behalf. So we have a project that we did with the town of Shediac, and it went from 2019 through till 2024. And we had, oh, my clicker's not clicking. There's 2 green buttons. There we go. No, I went too far. There we go. Ah, damn it. Come back. All right, there we go. So we built the province's first solar farm in Shediac. We converted 2 commercial buildings to net zero in Shediac. And then we also took 500 homes. So this is a community that is about 2,000 homes in the winter and 8,000 homes in the summer. Shediac is home to Parley Beach, which boasts the warmest beaches north of Virginia. So anybody interested in coming to Parley Beach, we'd love to have you. So we were able to get 500 out of 2,000 homes, sorry. So 25% of the community signed up to participate in this project. And what we wanted to understand is how can we better integrate renewable energy into the power grid? So 75 of these homes received rooftop solar paired with a battery energy storage system. Can we achieve cost savings when NB Power customers use smart technology at home? So all of the customers were given smart meters. Anyone that heated with electricity received smart thermostats. I will say in this community, 90% of the homes heated with electricity, 80% of those were heat pumps. For context, 80% of customers in New Brunswick, residential and commercial, heat with electricity, and 2/3 of our customers are on heat pump technology. So if anyone has questions about whether or not heat pumps work, happy to have that conversation with you afterwards, because we have been rapidly deploying them and using them for at least 15 to 20 years now. We're actually replacing heat pumps that were installed 15 to 20 years ago. And also, how can various technologies impact the customer experience? So it's not just about getting the technology into the home or the business. How hard is it for that technology, for that customer to adapt to that technology? What benefits does it bring to the customer? And benefits not just in bill savings, comfort, lifestyle impacts, a lot of different perspectives that we looked at here. And we also wanted to look at the potential benefits of time of day electricity rates on customer bills and peak electricity demand. So I do have to give a big shout out to the National Research Council, who we partnered with on this project, both because they brought their behavior science team. We were a bunch of engineers that wanted to test technology. We don't know much about our customers other than we like it when they pay their bills. So very grateful to have the support of the National Research Council in that capacity. And they also brought their data scientists, because you can just imagine all of that meter data, smart thermostat data, all the different devices. So they were able to do all that data analysis for us. And thank you, Jason, who gave us 50 cents on the dollar through Enercan, the Smart Grid Innovation Fund, because I can always build a business case around spending someone else's money. So what I'm going to focus on is the residential study side of things. I think there's a delay in my button clicks. Aha, there we go. So one of the things that we saw right off the bat, and we had seen this in previous studies as well, is that not every customer has the same load profile. So that means that there are things happening inside homes and businesses that result in different energy use load profiles, consumption rates, how high they peak, do they even peak? And that's what we really wanted to understand. So in this study and a few that we'd done before, what we realized was only about half of our customers peak when we peak. And NB Power, we peak between 7 and 9 a.m. in the winter on the coldest days of the year. And that is because everyone heats with electricity, and for decades, we've trained them to turn your thermostat down before you go to bed at night. In the case of businesses, turn the heat down because nobody's there overnight. And what that causes is our demand triples in the morning between 7 and 9 because everyone's heating systems are turning on at the same time. So what we really wanted to understand is, can we educate customers? Can we give them technology? Can we introduce new rate paradigms to help change that behavior? So one of the things that we observed is that all the houses, in addition to having different load profiles, had different behaviors. So because we had 90% of the homes on smart thermostats, we could actually see what is your comfort set point. Are you a 19-degree household? Are you a 25-degree household? And how much are you turning your thermostat down before you go to bed at night? So what that means to me is, how much are you contributing to the peak problem? So having that understanding of who's turning their thermostat down allows me as the utility to then target customers based on their behaviors. And what we found was that about 20% of the customers in the study that had central heating systems were turning down their thermostats the most. Anywhere from about 5 degrees on average, some years a little bit more, some years a little bit less, depending on how warm or cold it was that winter. But homes with electric baseboard or homes with mini split heat pumps weren't turning it down as much. And a big part of that is you had on average 1 control point for a central heating system versus 10 control points if you're in a house that has electric baseboard with mini splits. So easy to turn things down if I only have to touch 1 button before I go to bed, a lot harder to turn things down. So again, what's happening behind the meter is really important to understanding the customer experience. What technology do they have? What are their behaviors? Which technologies do they regularly interact with? And what that looks like for us, I got the right button, okay, is we can look at load profiles by heating system types. So this graph is all over the place, I apologize. And again, thank you, NRC data scientists, for presenting this in such an awesome way. What we see here, basically the green line at the bottom, that's homes that don't heat with electricity, right? So they're 50% lower than homes that do heat with electricity. And I think this day was only -10. So you can imagine that there's a much bigger differential between that bottom green line and some of the higher numbers if it's -15, -25 out. The dotted line in the middle, that's our average for everyone. So that's what we see as a utility, right? There's that average for everyone. I hate using the word average. On average, customers do X, because you're either above that line or you're below that line. Right? So if we say half of customers are 1-story homes, the other half of customers are 2-story homes, who actually lives in a 1.5-story home, right? There's like a few of them, but not many. So understanding what's happening in the home and how that translates into their load profile is really important for us when we're designing customer engagement programs, peak rebate programs, demand response programs, time of use rates, efficiency programs, everything. So this is essentially what that picture is painting for us. But as you can see, the customers that turn their thermostats down the most, which are central heating systems, have the highest peaks. They have the highest base load because they're bigger houses, right? They're two-story homes, and most of the smaller homes only have electric baseboard with some mini splits. So we expect there to be a difference in their base load, but their peaks are higher because they're turning their thermostats down. Who here has a programmable thermostat in their house? Lots of hands. Who has it programmed to turn down before you go to bed at night? Yeah, okay, so that's all of you I have to now try to convince to stop doing what you're doing if we're going to get to clean electrical grids. We also installed some cold climate heat pumps in the study. So these were heat pumps that had a COP of 2.13 at minus 25. So COP is a coefficient of performance, and that 2 means for every unit of electricity, so every kilowatt hour that goes into the heat pump, 2 kilowatt hours of heat come out the other side. So it's 50% more efficient than the electric baseboard. And we did see significant savings by just going to a heat pump, but what we wanted to do was compare, does the operating temperature and efficiency of heat pumps really make a difference? And the answer was yes. So the gray line on the top is heat pumps only rated to minus 15 Celsius, making sure that these heat pumps still had good heat output at minus 25, brought us an additional 10% savings for efficiency for the customer and 10% demand reduction for the utility. So something as simple as making sure that heat pumps are right-sized for the climate can make a significant difference. And price-wise, $200, right? That's an easy incentive for me as a utility to offer to bribe my customers into doing the right things. And what does that mean in terms of things like time of use rates? This one's a little bit confusing, but basically the dashed line on the left is under time of use rates, just looking at their load profiles, what percentage of customers would save. And what we were seeing originally when they were on electric baseboard, they would only save, or only about a third of them would see savings under time of use rates if they did nothing. Just by introducing a heat pump that still gave them savings when the grid was peaking, that moved up to about 65%. So just by helping that customer pick a better heat pump, they're going to see demand savings on time of use rates without having to change anything else about their behavior. So that's a really important piece for us, is that energy efficiency has a huge role to play in demand response. So it's not just about technology and it's not just about behavior. Those choices that customers are making are really important. This is another one that I think is important, is that we asked our customers, what do you think is the most energy efficient thing that you could do in your home? Turning down my heat before I go to bed at night. It's the single best thing I can do to reduce my energy consumption. Okay, that's a problem for us, right? And then the second thing was turning off the lights. When you heat with electricity, turning the light off when you leave the room, still important to do because it's a great habit to have. I don't even read that change at the meter, right? Because if you're using 200 kilowatt hours associated with space heating because it's minus 25 or minus 30 out, turning off that light switch does not show at the meter. So again, this is really important to understand that depending on where our customers are at, what is their energy literacy level? What do they believe in terms of energy efficiency, energy behaviors that will or won't impact their bills? If they don't understand the problem, they can't be part of the solution, right? So for me, this shows that there's a fundamental disconnect between the utilities problem and what our customers understand. So we need to, before we can encourage customers to adopt these technologies, change their behaviors, adopt time of use rates, we need a massive, massive energy education, energy literacy campaign with New Brunswickers to get them on the same page as us. So what does this mean in terms of AI? And then we're gonna jump to somebody else. There's a role for AI in terms of load profile analysis, right? So which customers are peaking when we peak? Because I can't turn something off that's not on, right? So there's no point in engaging customers that don't peak when we do. Virtual energy audits, really fast ways for us to get a sneak peek into those houses and then encourage them to go into an efficiency program and have an actual energy audit. Understanding the difference between energy efficiency and behavior change and which customers are going to benefit from basement insulation versus heat pumps versus behavior change, but also being able to give the right advice to those customers and making sure if I'm signing you up for a program, you're actually going to see savings, because if you don't, all you're going to do is bitch about the utility and convince your neighbors not to sign up for that program. And that's not what I want. I want you to be excited about your energy savings and how easy it was to partner with the utility and see your bills go down so that you can tell your neighbor to sign up for it. That's it for me.
So for those of you who are homeowners, one of the most impactful things that you can do for the climate is to get a heat pump. And switching to a heat pump for about 15 years, or its normal lifespan, has the same impact on the climate as being vegan for 15 years, or living car-free for 6 years. These are somebody else's slides. I'll flip through them if that's entertaining for you. Although if we can throw mine on there, that'll be great. I'll just continue without them until then. Okay, there we go. Okay. So this is a heat pump if you'd like a visual. It's an appliance that just heats and cools your home. And so having one for 15 years is the same as being vegan for 15 years in terms of the climate, or living car-free for 3 to 6 years. It reduces emissions by about 12 tons. Now, being a vegan is kind of hard. It changes 1,000 of your meal decisions per year, and in this room, 0 people requested the vegan option, okay? And living car-free is sometimes challenging as well, and so depending on where you live in Canada, it may not be feasible. So we wanted to develop a behavioral intervention that would reduce people's greenhouse gas emissions, and of these 3, one of them involves a single decision rather than things that you would change every day, so we focused on that. So my name is Jay. I'm a behavioral scientist, and I work at Impact Canada, the Privy Council office, and we did a collaboration with Natural Resources Canada and Environment and Climate Change Canada, trying to understand this decision that people make about switching to a heat pump. And so the first thing that we learned is that people don't think about their heating systems very much. And usually they only think about it when it's time to replace their heating system. And so if we're trying to give people information that would inform them about their systems and the benefits of heat pumps, we want to use the right framing. We want to make sure that we're giving this information in ways that are motivating for people. And so we talked with homeowners across the country, people that already had heat pumps. We asked them what motivated them to get a heat pump. And sometimes they said cost, sometimes they said climate. And so we kept these motivators, but there was one thing there was no one single motivator that pulled them to get a heat pump. Next, we thought, okay, when should we give this intervention? So the timing is important. And heat pumps usually break down in the winter. And we found from our studies that when they do break down in the winter, people tend to replace the same system for the same system. And so this kind of makes sense. If you go home from this conference, your house is cold, you're probably just going to replace your natural gas furnace with another natural gas furnace. You're not going to spend the time looking for alternatives. So we wanted to give people this information up front so that they would be able to plan. And finally, we had to think about the messenger. Where does this information come from? And unfortunately for the government, people tend to not go to the government for information about heat pumps. They tend to go to their utility. And so with this in mind, we partnered with a utility, Toronto Hydro, and we ran the largest behavioral study on heat pumps. So we took these 100,000 households, we randomized them into different conditions. So some of them were in the control group, so they got no contact. And the rest of them received an email from Toronto Hydro that would frame the advantages of heat pumps in different ways. So some of them learned about the functions of heat pumps, that they both heat and cool, so they can replace your furnace and air conditioning at the same time. Some people learned about social norms, that they're becoming more popular across the province. Some of them air quality benefits from not burning fossil fuels, and the environmental benefits that we spoke about, and then a combined condition that stacked up a bunch of these different advantages into a single email. And so if you're from Toronto, you may have received one of these emails a few years back that framed the advantages of heat pumps in these different ways. So you'll see that they vary based on the kind of the subject line that they have, the tagline at the top, the amount of content that there is, but most important, the framing of the content. So what kind of info we're providing. And we were trying to figure out which of these interventions would be most effective at driving heat pump adoption. And so I want you to just skim through these, and then we'll have a vote, an informal vote by show of hands. This is supposed to be challenging, right? We won't have time to read the whole thing, but we'll just take a vote. We'll go one by one, and the other panelists have to vote as well if they haven't seen this research as well. They're not off the hook. So how many of you say that the functions condition, the first one, is the most effective driving heat pump adoption?
As an engineer, of course.
Okay, okay. How about the social norms one? Okay, environmental, air quality. Okay, and finally a combined condition. Okay, great. So for those of you who raised your hand for social norms, environmental, air quality, or combined, all of the one of the last four, just raise your hand and hold your hand up high if you raised your hand for any of those. Hold them high, proudly up. Look around the room at all of your friends and colleagues who are all wrong.
Go engineers.
Yes. And sheepishly, I must admit that I was also wrong about this. My team was wrong about this. And every single group of experts that we've asked, behavioral scientists, policy analysts, and topic matter experts, have all been wrong about this. So that's why it's hard to predict, so we test this. The first thing that we looked at is open rates, right? Who saw the subject line and then opened up the email. We didn't see a lot of variation there. The social norms one was maybe slightly higher. Next, we looked at click rates. At the bottom of the email, there was this button that said, click here to learn more about heat pumps. And there we found the functions and the social norms ones were performing the best. And these were also the shortest messages, and so it's possible that that button to click here to learn more was just the easiest to press. But most interesting for all of us is 1 year later, who got a heat pump versus not. And we found that the functions condition was the most effective at driving heat pump adoption. Now, zooming out a bit, okay, we see the same pattern across these different variables. Functions and social norms performing the best for open rates, click rates, and adoption rates 1 year later. And zooming in on that functions group, we found that it was the most effective in low-income neighborhoods. And we thought that this might be because low-income neighborhoods might have older homes, less likely to have AC. So if they can replace their furnace and get cooling kind of for free, then that might be a benefit for them. So overall, in this functions condition, we saw 4% growth in heat pumps above and beyond what we got in the control group. And so this 4% might seem kind of small, but this was an email, right? For every 94 emails that we send out, one additional person got a heat pump. So it was an extremely low cost and scalable intervention. And for all these emails combined, there was a total of 348 new heat pumps installed due to the emails above and beyond the control group, so above and beyond the natural growth in these. 348 heat pumps over their 15-year lifespan, the same impact on the climate as turning 5,000 people vegan for 1 year, although it's a lot easier to convince them to just change their system from here. So, thank you. So, how did we infer who got a heat pump and who did not? So, we hypothesized that people with a heat pump, when it's colder out, okay, so as the temperature drops, their electricity use would be higher. And so we asked a subset of these households whether or not they had a heat pump. I'll show you two kind of cherry-picked participants here. The one on the right, there's basically no relationship between the temperature and their electricity use because they're getting their heating from something else. That's the one on the left, rather, that flat line. And then the one on the right, as it gets colder, you see higher electricity use. So using this, we developed a model looking at 2 years of electricity usage data provided by Toronto Hydro prior to the intervention, and then we sent out the email, and then we tracked for 1 year after. So people that went from more of a flat line, like no relationship, into more of a correlation here, we could assume that they got a heat pump. So we were able to predict this using a sample of them in order to validate this. And so moving forward, we're testing this heat pump detection method and this intervention in another sample of 50,000 homeowners. This was sent out in the summer. And there's a new condition here that we're testing on finances. And this time we kept all the lengths of the emails the same so that we didn't have this confound of the message length changing. So 3 main points. The first one is that we can use behavioral science in order to have these really low cost and scalable ways to increase uptake of technology. We've talked a lot about technologies at this conference so far, and the technologies only matter if people use them. And so we can use behavioral science in order to increase uptake in this way. But we have to think about the context. We have to think about if there's this intervention that we're sending, who's it coming from, what does it contain, and the timing of it. We have to really zoom in on these really important decision points. And finally, as we all saw, prediction is hard. So trying to predict what's going to work and what's not going to work is really challenging. And from that first study, in terms of heat pump adoption, the functions group was 28 times more effective than the combined group relative to the control. And that was something that nobody predicted, basically. And so we don't have to have the expertise to know what will work and what won't work. If we test some things, we can choose the thing that works the best. And so we're hoping that using these kinds of behavioral science interventions, scaling them up across the country with other utilities, we'll be able to reduce the greenhouse gas emissions and increase energy efficiency across the country. Thank you.
So right now I'll talk about the subject where I have 2 people working on one of the maybe 60 projects we have basically under my team. So it's a detective. It's about vegetation management. So basically, let's go ahead. Oh yeah. So at the placeholder of the slide 2, you should have seen an amazing video of a LiDAR. It's a car running in the road, and with the LiDAR, you see all those dots point. So basically, Detective, what it is, it's a project where it's using AI, HD imagery, and LiDAR to map the roads. So basically, with that, we're mapping everything, power lines in the front lots of the electrical system, and it's giving us the opportunity to really scan and see those trouble area where we may need to do vegetation management, because in Quebec, we did stop for several years to do vegetation management. It's a mouthful. And so we did have issues after that about reliability of the network. So we're trying to catch up right now, but there's so much to do. We really want to aim those places where it's the more cost effective. And yeah, so the placeholder is slide 3. You had an amazing video where we were seeing going through a street, and you see the AI model recognizing, oh, 1 minute? All right. That's slide 2. So you can see the video here about the LiDAR, basically going down the street. So that's part of it. What we do, we really like combine the AI model, the LiDAR, and the HD imagery to combine and do one solution. So maybe we could try slide 3. Yeah. The 2 slides you put externally. Yeah, exactly. That was a trick to get it out. I had to split my presentation. No, I don't have a good joke, sorry. Oh, yeah, so here you go. Does it work? No, or maybe it's mine. Okay, yeah. So you can see here in the video the example of the AI model we're running with the imagery. So basically with that, we can really scan the network, and we did train it to really detect every part of the distribution network here to give us help to work on the topology and see which one would need an intervention first. So yeah, that's pretty much it. All right, great. So another part of it, what we could do with that project is use this project to detect older transformer in the poles. We do have older transformer with PCB. That's pretty nasty liquid stuff. Has tendency to cut fire after several years. So we're trying to replace those before. So that was a good way to have something in detect what could be prioritized first on the network. So that's a good use case we had for that project. And also to read those tags we have there, we call it, it's a letter number, etc. That's another slide where we show we're not only scanning for the vegetation itself, but we really like detect the species of the tree itself, because we know some of them are more prone to failure with those ice storms. For example, I don't know, a silver maple, I believe we say in English. So this one is pretty weak. So if they have a certain amount of ice, the branches will collapse on the power line. So those are prioritized in the project. That's why we did that. And it's pretty good. We had an amazing database of 2.26 million pictures for all the trees we have in Quebec, all the species. So we can identify 150 species. So that's pretty good result right there. Here another example where we see the LiDAR view, where we can detect the branches over the wires, where we want to intervene first. And as you can see, depending of the species of tree, some of them are more prone to have failure. So you'll see in red compared to yellow and green. And what we did with that project then, since it was more for the front lot, we said, okay, let's do a hackathon and try to find some other way to improve. And another way for that was with that hackathon to try to introduce help for the consumer. So we wanted them to participate in that way with their phone and encourage them to take pictures from the backlot and maybe have our own version of Pokemon Go, or, you know. And we want to gamify a little and try to bring a customer to participate and give us a hand in improving the network reliability. So basically what will bring that from, that was the main pitch that win the hackathon. And so what we'll do at the end is to try to bring it in the value chain of the project itself. And where you see in kind of pink, orange is where we can swap some AI models and improve and use that supply chain to really like improve some other projects we can have with the collaboration of consumers or maybe even like other businesses like telecom companies to work with us and improve the network. And that's it.
Okay, well, thank you all for those are amazing presentations. So I think we've heard examples of the utility working to nudge the customer, right? To consider ways that they can help the utility. And what's interesting about this space is that the customers never really had to consider, how much they have to help the grid to this extent before, right? Their own energy management and even, helping with veg management as well, right? This is a totally new space to them. And on the utility side, I think the utility hasn't really had to consider like the personal preferences of the customer as intimately as they have before. And so from the utility perspective, if I'm planning on the customer as an asset, as a resource, I want them to show up. As the customer, I have certain non-negotiable needs and preferences, and above that, I have to think about what's in it for me, right? So I think there's a culture change involved on both sides of the coin there. And I think Niels at Schneider wrote, hashtag relationship goals yesterday. So let's dig a bit deeper into kind of how we get acquainted and build that chemistry. So maybe my first question is for Sarah and Jay. You both had the opportunity to work with hundreds of customers, right? And I know, Sarah, you've got a number of stories that you could share about the customer experience and just how, it's impossible to overstate how important the customer experience is to the success of these programs, right? And so I was wondering, maybe like a sort of a combined question, is that how do you achieve getting the customer to buy into these programs, especially for those hard to reach customers, right? And what's their ability to adapt to change? How do we not leave customers behind? What should be our expectations for rollout?
Yeah, I think the biggest part of that is for the utility to develop a very deep understanding of who their customers are. And right now, we only think of our customers as, are they high demand users? Are they low demand users? What's their total consumption? What's the business proposition? What's the ROI? But we really need to look at it in terms of their energy values. And so if we look at like the UK and New Zealand, they're doing a lot of work around what's called the energy culture framework. And they start their conversations with the customer in 3 areas, which are think, have, and do. So think is, what does the customer believe? So if I do surveys of my customers and they say the number one thing that I can do to save energy in my power bill is turn my thermostat down before I go to bed at night, if that's what causes my grid peak, I have a big problem, right? So if that is their belief, how can I go to them and say, your belief is wrong and I need you to change that behavior? Especially when we, at the current moment, have efficiency programs in market that we're paying people to go get a programmable thermostat and turn it down before they go to bed at night. So we are causing the problem that we're trying to solve. So this is where there's that disconnect, and we really need to start working together. Customers, utilities, but even different departments within our utility. Our demand response team and our efficiency team need to be talking to one another, because we can't be asking our customers or giving our customers incentives to do something they shouldn't be doing from a grid management perspective. The other piece, I think, is, as an engineer, I don't know anything about behavioral science. And I will honestly tell you, the first few behavior type projects I was involved in, I thought the marketers and the behavior scientists were crazy. And thankfully, they were very patient with me and used their behavioral science magic on me to convince me to see that, no, behavior science is a science. And as an engineer, I got there because they showed me data and pretty graphs. And this is where, again, it's those partnerships. So we need to work together, utilities with behavioral scientists, to make sure that I can design a rate that works for the utility. But does my customer understand what I'm asking them to do? Do they understand the value proposition for them? And does that value proposition align with their values and their beliefs? But also, do they have the means to do it? So do they already have technologies in their home they can use, or do they need to go buy them? Do we need to give them incentives to go buy those things, right? And where are they in terms of life stages? Seniors? Some of this stuff is hard. And as Jay said, we have customers in this pilot project, a lot of seniors that quite literally ripped their smart thermostats off their walls and brought it back to us saying, I hate it, I hate it, I hate it, right? It was just too much change. They lived with their dial thermostat for 60 years. Now I have an app on a phone. We had to give people tablets so that they had a device that they could put an app on to control their thermostat. Too much change. So you need to know which customers are compatible, both on their existing behaviors and load profiles, but think, have, do. Are they in the mental space to even adapt to what we're asking them to do? And that's why I need people like Jay to help me figure that out. No.
That's great. And Jay, if you add on to that would be great. But also, can you maybe speak to what's the cost of perhaps getting the messaging wrong? Right? Like if maybe there was a miscue, right, in the way that goes out, how does that impact the customer perception and your eventual rollout?
Yeah, sounds good, thanks. Maybe there's 2 responses that I have. The first one is that the people that we're trying to target, usually we go for what can we call the movable middle. So if we're trying to get more heat pumps out there, there's some people that have adopted them. There's a big movable middle that if they had the right information, they would be happy to switch. And then there are people that just hate heat pumps. And these people that hate heat pumps, that's fine, but they're not the target that we have. And that there's still a lot of low-hanging fruit. These people that would change, but all that they need is just an email that shows them here are the advantages and here are the steps that you take. And so I think in terms of having the greatest impact, we target the people that are on the middle that just need that small nudge, and they just need some well-framed content that would change their mind from there. And then in terms of the cost of getting that wrong, sometimes people, they'll learn about something, they'll make up their mind, and it will stick for years. And so when I first learned about quantum stuff, I thought it was kind of scammy. And then I thought, this is nowhere near development. And then I believed that up until literally yesterday. learning about that stuff, right? And so sometimes if you send a communication, or if something's too complicated or too challenging, people will just make up their mind, and then they stick with that, right? And most people, they're not motivated to seek out information about where they may be wrong here. And so I think it's important that we try different things, we find out what's working, and then we scale it from there. Because sometimes these decisions that people make, say for what they're changing their furnace system to next, this can lock in their carbon emissions for 15 years after. And so if we get it wrong once, then it's really hard to change after.
Great, thank you. So I'll move on to Sébastien. I'd like to ask you about placeholder 4. No, but your project was interesting, right? Because in this case, you're not asking the customer to reduce demand, right? You're asking them more to partner with Hydro-Quebec with their vegetation management, right? So I think in that case, the benefit to Hydro-Quebec is clear, right? But to get the customer involved, can you speak to how you're communicating the value prop to the customer, right? To get them to participate in these programs. Because if you want to scale or roll this out, right, across a broader customer base, like myself with an app, how do you convince me to get in on this?
Well, on the first part, what we're trying to do is to involve customers to, if they do have like problems, they can take a picture in the backyard and say, oh, I have an issue. So in this way, we'll be able to process the information way faster. Also, we do have like those calls where people were calling on the phone, we have no clues, and say, oh yeah, that's an emergency, but there's only a cat in the tree, So we're moving a whole team, and it's costing us money. So in that way, we'll save a lot. But also, mapping the network in their backyard itself. That's why we're aiming for stuff like maybe we're trying to think about gamification, which will bring motivation to the customer to participate in that. Because as you know, you don't see much transfer picture on Instagram. It's not a popular subject if we compare to cats. So we have to bring something very interesting to make sure they are taking pictures and participating. So that's why we're trying to see what we can bring them, what's in it for them. So maybe like just recognition, or maybe rebate on their invoices. So that's part of the project right now.
Great. Yeah, you should partner with Pokemon Go, right, to get the Pokemon in the trees.
Exactly.
Yeah, exactly.
Bulbasaur and Poultry.
Okay, so I think we have time for one more quick round of questions. And maybe the question to all three of you is probably recognizing that today we have access to data that we never had before, right? And that allows for a certain extent of personalization, right, with the customers. There's also privacy issues. So I'm just curious, from each of your standpoints, where do you see the role of data and AI and computing and all these new capabilities in really supporting the utility, right, with these programs, and kind of where do you see that going in the future, but also effectively helping provide customized solutions to the customer, right, to improve their overall experience, to kind of get that buy-in. So maybe just we can come down the line if you want to start, Sébastien.
Well, for us, first of all, with private data, it's always a big challenge, because in Quebec there's a Law 25, which brought some issues accessing the data itself. So that's why everything which is like customer related really have to be internal to Hydro-Quebec. Even in Hydro-Quebec itself, it's hard to access some data. So that's why maybe like getting the data, training the model, and then spreading the model is way easier than to access the data across the tools. So that's why we're looking at those solutions.
What I'm hoping for from my end is more kind of personalization, kind of like when we were talking about in the lower income neighborhoods, there were certain communications that work best for them. I feel like that's something that I'd like to see utilities do more of, where usually the communications are just sent out broadly, and they can have the data on tracking the effectiveness. And so maybe in a particular neighborhood, maybe there's a lot of people in this movable middle there, where if they sent them this kind of info, then people are more likely to swap to a heat pump, and then they'll tell their neighbors about that, and then it would kind of spread from there. And so I think that there's a lot of possibilities for this kind of personalization and providing the customers with the kind of info that resonates with them the most.
And I think our biggest challenge is going to be that in order to use data effectively, we need more data. Because to your point, how do I know who the movable middle is? So how can I target the right customer with the right solution and the right level of data? So again, a senior that still has a flip phone that can't put an app on it, I'm not going to get them to be able to participate in Sebastiana's program, right? If they're a senior that's set in their ways and too much change is quite literally going to be stressful for them, that's not a good relationship we want to have with our customers. So being able to target your customers based on who they are means we need to start getting a lot more information about our customers. That can be as easy as a survey, but even then we know certain types of customers answer surveys. Certain types of customers don't answer surveys. So it can't just be a survey. There have to be other ways that we can easily engage with our customers. So this, I think, is going to be very interesting going forward in terms of that ability to customize to the needs of the customer, but we really need to engage in a big getting to know you exercise with our customers so that we can provide them that right solution tailored to what they already understand, giving them the right level of information that doesn't overwhelm them, or I'm not even getting to the click here button because the email's too long.
Awesome. Well, thank you. Yes. So we have a couple minutes for questions. So please, yeah.
Yes. Last year, Siemens, at our forum, Siemens explained this experience. I don't know if you worked with Siemens for this thing. And it was so interesting because we had the point of view of the fabricant, of the supplier of equipment. And he told exactly the same thing than you.
Glad we're aligned.
He said that some population, he was not sure that it was a typical behavior because there were a lot of senior, and also it was in one corner with some building characteristics, so we were not sure what it would be with poor or old buildings, or if the behavior was the same. And also I would like to jump to the Anana from Polytechnic discussion we had yesterday. Maybe is it possible if you think that we could have some discover or classify or do a roadmap of the different populations just in collecting data from the counter or from the... Do you understand my point? Just to collect data. Is it possible to characterize customer profiles in collecting data?
Yeah, we can collect data and have a profile of customer, but after that, we can't share it. It's against the law.
And you can adapt an approach.
Yeah, we can internally, yeah.
I think the question of Marie, it's actually can we cluster consumers? Because in your project you mentioned 800 houses, but let's imagine we want to apply this on a scale of a province like Quebec or any type of other provinces. Are we able? Yeah. Are we able to create clusters of consumers?
Yeah. So from that perspective, we would have some customer clusters that we use at ME Power, customer segments as we call them. So what percentage of our population is low income? What are different education levels? And how do each of those factors affect our customers in their values, their ability to adapt to their decision making, and all that kind of stuff. So we do know that the town of Shediac was a little higher educated and a little bit more affluent than the rest of New Brunswick. So we can take what we learned and then say, okay, if we were to apply this same study to a larger segment, how do we think this would play out? We did look very closely at demographics of the households, not just how big is the house, how well insulated is the house, but also how many people live in the home, right? And again, we asked them questions about their values and beliefs. And what we learned about the town of Shediac, and even how we got to this project, was because they believe in community. And they believe in, if we all work together, we can achieve something really great. Not every community is so close-knit. So there are going to be pockets in New Brunswick that don't share that same sentiment, especially since we just went through municipal reform, and there were quite literally communities that hate each other. They now have to learn how to get along. Yeah, anybody ever go through municipal reform? Good luck. So that's the challenge. So we know that there were certain things that worked in Shediac that won't work in some other communities, but they will work really well in others. So again, it's that deep understanding of your customer. So we need to now sit down and say, based on what we learned, how scalable do we think this is to the rest of New Brunswick? Some of it might be unique to Shediac. Some of it might be reproducible in other areas, and we might just say we're not touching that community or that community with any of this kind of stuff until they work out their problems.
Okay, so I think we're at time. So I want to thank our three speakers, Sarah, Jay, and Sebastien. And I think just to close out, people are hard, right? It's hard. And if we want these demand response programs to scale up quickly, we got to work with people. And I think that's just a new frontier for the electricity sector, and certainly something that we're working through. So thank you for sharing your insights, and hopefully everyone enjoyed the talk. And please feel free to reach out to them afterwards. They have lots of stories they can share on these fronts. So thanks again.